Hey everyone, good morning. Am I audible? Please let me know in the chat box. Yeah, thanks for letting me know. So, yeah, welcome to day two of our VLSI design and verification free course. Yes, I hope you have all watched the recordings. If you haven't attended the live session yesterday, so please confirm me whether you can able to access the recordings. Okay, that's great. Okay. So let's start today's session. And from this session, we are going to start with digital design. Okay. So in this particular module, we are going to discuss few things. First, let me show you what exactly we are going to discuss in this particular digital design, and let's move forward with our session, right? And everything about the course and duration of the course and class duration, the content, and everything has been discussed yesterday itself. The introduction, everything has been given yesterday. So if you haven't watched the recordings, I recommend you to once go through them so that you will have clarity exactly what we are going to deal and all, right? Yes. I hope my screen is also visible, right? Please confirm me. Okay, that's great. Yeah. Now, in this digital design, as we have discussed, that this digital design is the fundamental and the foundation of entire design and verification. And many of you have already learned this particular course in your colleges, in your UG or PG or anyway. And that's the reason we are not going to focus more upon theoretical part. We are going to focus upon more problem solving, right? So, anyways, we are also going to deal few particular theory concepts, and we are going to jump into more problem solving, right? Now, in this particular digital design course, we are going to start discussion about number systems. So, this is the very first chapter we are going to deal. And afterwards, we are going to, after completing the theory, we are going to discuss, some 50 to 60 problems. And as I've said you, most of the problems, like I will be dealing few problems in the session, and I will be giving you assignments so that you can solve them on your end. Okay. And next is Boolean algebra and logic gates. So we have Boolean algebra, and logic gates will also be covered over here. And next we do have something known as combinational circuits. So in this combinational circuits also, we are going to first of all look into the theory, and we are going to have problem discussions. And next is sequential circuits. Okay. So these are the four chapters we are going to focus upon, and we are going to discuss this in great detail. Okay. Now, let's start with this number systems without any delay. Now, in this particular number systems, we already know that we have different kinds of number systems, different kind of bases, right? Now, what are the different kind of number systems? Do you all know? Can I know in the chat box? Like, what are the different kind of number systems? Do you know? Can I know in the chat box? Octal, hexa, binary, and decimal. Binary, octal, decimal, and hexadecimal. Okay, great. Okay. So we do have number systems like we have binary number system, which is basically base 2, and we do have like octal number systems, which is basically base 8, and we have hexadecimal number systems, which is basically base 16, and decimal number systems, which is basically base 10. And I have a question over here. So we only have only this particular four number systems, or can we have like base 5, base 6, or base 12, 13? Can we have those number systems, or only we do have only this exact four number systems? We can have any base, exactly. Okay, it's not like we do have only this four bases. We can have any base. Okay, now, what is this binary number system? Where it is used for? What is the application of this binary number system? Where are we using it? Anyone wants to answer? Okay, let me also enable the mic. If you want to answer, you can also unmute your mic. Unless and until if you want to answer, you can unmute your mic. Yeah. So it is basically used in computer language. Okay, systems understand binary language. Okay, Any other answers? What is the application of this binary number systems? So I will try to have this entire course in application oriented manner so that we can in interviews we can basically able to give our answers in more application oriented digital communications. Okay. Any other answers? And let's keep this session interactive so that me and you will not be feeling bored and for this duration, right? Yeah. Okay. Someone has answered that we are going to use it for computer language. So does really hardware understands zeros and ones? Does really hardware is going to understand binary or it is going to understand zeros and ones? Exactly. So hardware is only going to understand voltage levels. Exactly. So as we are human and we cannot, deal with voltage levels. So what are we going to do is we are going to represent a low voltage with logic zero, that is binary zero, and high voltage with logic one or binary one. Exactly. So as I've said this particular point, let's say if I'm going to represent this low voltage or voltage zero with binary zero and high voltage with binary 1, okay, and high voltage with binary 1 or logic 1, right? Can I do this vice versa if I'm representing like this, right? And can I change the representations, like for high voltage can I use logic 0 and for low voltage can I use logic 1? For low voltage can I use logic 1 and for high voltage can I use logic 0? Is there any uh, error over there if I am going to use it? Okay, let me repeat my question again. So for low voltage, if I'm going to use logic 1 and if for my high voltage, if I'm going to use logic 0, is it correct or is it wrong? Or is there any rule that we should not, flip them or we should not follow the vice versa option? Okay, I'm getting few responses in the chat box. Great. Exactly. If we are performing the vice versa operation, that is nothing but my negative logic. So whatever the logic which I'm representing, right? This logic is known as positive logic representation or positive level representation, right? Now, if I'm representing them in the opposite ways, like high voltage is basically if it is being represented with logic 0 and low voltage if it is being represented with logic 1, this is nothing but my negative logic representation. That's it. There is no such rule like you should only follow this positive logic or you should only follow this negative. No, you can flip them. Is it clear, guys? Exactly. Now, and coming to the other kind of number system, which is octal number system. Okay, and in binary number system, as it is base 2, we are only going to have two digits, but that is 0 and 1. This is obvious, right? Now, in the case of my octal number system, first of all, what is the application of this octal number system? Like, where are we using it? Where can we use it? Any answers? Okay, ALU. What happened? Only one answer. What about others? No idea. Where can we use this octal number systems? What may be the application of this octal number systems? Processor. Okay. Why are we learning it? So there must be some purpose, right? Okay. So when we are processing any particular data, let's say if I'm processing some particular data, if I'm adding some data, or if I'm subtracting some data, or multiplying some data, or just loading some data from a memory. Let's say I have a random data 10110 1110110 111 so this is some random data. I'm going to, perform some addition or complementing or, just some kind of multiplication or something. Someone has mentioned ELU, right? In that we are going to do something, right? Now, instead of dealing with this many number of digits, what we can do is we can just find out an alternate representation that is nothing but my octal representation. So instead of dealing with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 digits, instead of dealing with this 14 digits, I can basically convert it into octal. So what happens if we convert it into octal? What is the number we are going to get, guys? Can anyone convert this number into octal, and can you tell me if anyone knows how to convert it into octal format in the chat box? Exactly. 4 2 6 6 7. I'm trusting your answers and I'm writing down over here. It is 2 6 6 7. That's it. So you need only 1, 2, 3, 4 digits to represent some random number. I don't know what is that particular number in decimal. If I'm going to convert, then I'm coming to know. But not that's not the matter. So some random number, if I took, and that particular decimal number I can represent in binary, it is going to take so many number of digits. But if I am going to represent in an octal, it is going to take only four number of digits. Okay. So basically, it makes humans to read it and manipulate it. It is easier to us to read it and to manipulate it. That's the reason we are going to other kind of alternate representation. Is it clear, guys? Now, other kind of representations is also for the same purpose. So in the case of your hexadecimal number system, can anyone tell me the value in hexa format? What is the representation of the same number in hexa format? 5b7. Great. I got one answer. And what about remaining people? Is the answer correct? Okay, I'm getting different answers. One is 5b7, another is 4b7. Okay. So you should group them into four. 5b7. Okay. Okay. So answer can be anything, 5b7 or 4b7. So you're going to have only three digits, right? So can you see the difference between your binary, octal, and hexa? So the number of digits you are going to use. Okay, I'm getting one more answer, which is 2db7. Okay, it may be anything. But the conclusion over here is the number of digits you are going to use for representing this particular number as moving on. Okay, 2db7. Okay, great. So the number of digits you are going to use for representing this digits are getting decreased. Okay, 2db7. Is it clear, guys? Okay, so this is the difference between your binary, octal, and hexadecimal systems. Okay. So any doubts or any queries over here? Shall we move forward? Yes, just now I've told, right? So if you are having larger numbers or larger value numbers, then for representing them with least number of digits, you can use your hexadecimal numbers. Okay. Now let's move forward and let's discuss this. Yeah, you can think of using it in your memories and all, where if you're and your ALUs and your processor, and when you're going to write your code, mostly in your specifications, also you're going to represent your larger data with your hexadecimal number systems only. Okay. Yes. Now, so let's move forward and let's see some conversions. Like if I want to convert any number into from binary to, let's say, octal, how to convert it? So this particular session, I'm just trying to revisit all the theory part which is needed for the problems which we are going to do from tomorrow. So this is just like a kind of revision or revisiting. Okay. Yes, we are going to basically perform group of three. Exactly. So here we are basically going to perform group of three and we are going to convert binary number into octal number. For example, if I'm going to have 0, 1, 1, 0, 1, then we can basically group this 3 and this we can group of 3, which is nothing but this is 5 and this is 1, which is 15 to the base 8. Now, can anyone tell me this value? 182 base 8 in binary. Let's see who can answer this question. So, can anyone convert this 182 base 8 into binary and let me know? Waiting for your responses. 182 base 8. Okay, I got one answer. Exactly. So in base 8, we don't have a digit, which is 8. Okay. So this you should check it out. So we are only going to have the digits from 0 to 7. Now what will be my answer and how to convert octal to binary? Exactly. Using 4 to 1, we are going to convert it. That is nothing but 0, 1, 0, 0, sorry, triple 1, and which is 0, 0, 1. That's it. Base 2. Okay, exactly. Correct. Now, let's say if I want to perform the conversion from binary to decimal, then what will be the process? Let's say if I have a binary number 1011 base 2, how to convert it into decimal base 10? Exactly, multiply by power of 2. Just we are going to add the weights. So it is nothing but 1 into 2 power 0 plus 1 into 2 power 1 plus 0 into 2 power 2 plus 1 into 2 power 3. Okay. So this is nothing but 8 plus 2, 10 plus 1, 11 base 10. Okay. Yes. And let's say if I have octal number and if I want to convert it into hexa format, then what is the process, guys? Let's say suppose if I have 571 base 8 and if I want to convert it into hexa format. So what is the process we need to follow? Octal to binary, then to hexadecimal. First convert it into binary, octal to decimal. Exactly. We have multiple ways. We can either convert it octal to decimal and we can, you know, convert it further to hexa, or else we can convert it into binary and we can convert it into hexa, right? You can follow any other process. And what is the answer you are going to get? What is the answer for this in hexadecimal format? 178. Exactly. Everyone getting the same thing or any other different answers? Okay. I think everyone is getting the same thing, right? 178. Okay. And I hope you all are aware in hexadecimal numbers. Up to 9, you are going to represent it normally, and 10, you are going to represent it A, 11 is B, 12 is C, 13 D, 14 is E, and 15 is F. Okay. Yes. And I hope everyone knows all the basics. So that's the reason I'm not going in, great detail and explaining the things in great detail. So I'm trying to focus more upon problems. So this is just like a revisiting the theory part and all. So is it okay for everyone, right? Is there anyone like you need to have the detailed explanation of each and everything? Everything is good, right? Yes or no? Please let me know in the chat box. Okay, fine. Now, let's say if I want to convert from hexadecimal to octal, what is the process? Again, the same thing we are going to follow. Either we can convert it into decimal and from decimal we can convert it into octal format, or else we can convert it into binary and we can convert it into octal format, right? Now, let's say if I'm going to have a particular, okay, from 0 to, this is my decimal number 0, and in octal format, I'm going to write it down as 0 only. And 7, I'm going to write down 7 only. This is my decimal digit 7. Okay. Now, what about my decimal digit 8? How to represent decimal 8 in octal format? What is the value? 1, 0. Exactly. And followed by 9 is 1, 1, 10 is 1, 2, 11 is 1, 3, 12 is 1, 4, and so on. Okay. Up to 1, 7, you're going to do. Okay. Now, let's say if I want to convert any number, it may be binary, it may be octal, or it may be hexadecimal. So if I want to convert any number, it may be binary or it may be decimal, sorry, it may be hexadecimal or it may be octal into decimal format. What is the process, guys? What is the process we need to follow over here if I want to convert binary, hexadecimal, or octal into decimal? It may be any number. If I want to convert a binary number or a hexadecimal number or a decimal, multiply it by weight. Exactly. So you should basically add the weights of each and every particular digit. Okay, that's the reason I'm asking. So sometimes we get confused whether to divide or to take the weights and add. So that is the reason I'm asking over here. Okay. So we need to basically add the weights. Okay. Now let's say if I want to convert any decimal to BHO, then in this particular case, what is that we are going to do? Prime factorization, or sometimes it is also known as continuous division, and we are going to take the result, right? Yes. So that is how we are going to convert from one number system to another number system, right? So that's about the revisiting and revision of all the theory which is needed for performing the problems and all. So from tomorrow, we are going to start with problems. And what will be the format of those particular sessions is I will be giving you or displaying you the problem. So basically, you can take 2 minutes or 5 minutes of time and you can solve it. So like that, let's see how many problems we can do in the session. And remaining problems, I will be providing you in the PDF format in the group so that you can solve them and you can come up if you're having any particular doubts and we can have the discussion, or else if anyone is not having any queries, we can move forward with new topic. So that is a format which I'm planning. Okay. Yes. So that's about this particular session. If you have any doubts or any other queries you wanted to discuss, you can stay and discuss with me, or else we can wrap up this session. Okay. Thank you. Have a great day.